Welcome to part 3 of this series in factoring quadratic expressions. This next one here is so the methods we've talked about before will work pretty much with all of these. But these are special patterns where there's one where you really do need to know them and recognize what it is, otherwise you'll have some difficulty. The other one is more of a kind of a shortcut. If you can recognize and use it, awesome, fantastic. But the other methods that we've talked about here work a little bit better. Now I have this blown up so we can see this a little bit better. Maybe you want to take notes on this, but here are the two patterns that we have. We have the difference of two squares. Remember, difference means that we are subtracting in two squares. So if we have a binomial, so a two-term thing, and we recognize that the first term is something squared, and the second term is something squared, and we're subtracting between them, they factor into this really cool pattern where it's a plus b times a minus b. Like in this example that they give us here, x squared minus 4, x got squared here, 4 got squared here, 2 got squared here, 2 got squared here. So this turns into x plus 2 times x minus 1. X plus 2 times x minus 2. I apologize for the misspeaking there. The thing that you got to be careful about this is you always want to be recognizing what got squared in this case. X got squared here, 2 got squared here. I'll run over the other one here really quickly, and then we'll look at some examples. A squared plus 2ab plus b squared equals a plus b squared. This is called a perfect square trinomial. And what this means is if there can be a trinomial, a three-term thing. If you recognize, okay, the first term is a perfect square, the last term is a perfect square, maybe this falls into this special pattern. Let me run the special pattern by you really quickly, and then we'll come back and talk about this. I'm going to reduce my screen size on this a little bit, though, so it'll let me. There we go. That's at a better size for what we need to do. So let me show you a quick example of this. An example that I've done recently in class involved something along these lines. If I can get my thing to work. If I had the expression, say, x plus, I'll mix it up. Let's do 3. No, let's do 4. Let's do 4. X plus 4 squared. Okay. Remember what this means is this is really x plus 4 times x plus 4. And when we FOIL these out, x times x is x squared. Outer x times 4 is 4x. Inner 4 times x is 4x. And my last term is 4 times 4 is 16. So we're not quite done with this, so we have to combine our like terms here, our 4x and our 4x. So we get x squared plus 8x plus 16. So notice with this here we have 16, which is a perfect square. We have x, which is a perfect square. And notice how we got this 8x. We had a 4x and a 4x added together. 4x plus 4x. And notice how it's this is x plus 4. So a 4x and a 4x. We had two of those to give us an 8x. So with that example, let me run through an example actually with the perfect square trinomials here. Let me get this cleared off. Get that deleted. Let's look at an example here. This one here. All right, so we have a few examples here. I'm going to ignore this for a moment because I want to talk about this one because I'm really, really excited about this right now. We have 9x squared, and I need to increase my line weight. All right, 9x squared plus 24x plus 16. So looking at this, to see if this is going to fall into one of our special factoring patterns, we need to ask ourselves, is this a squared term? Did we square something to get this? Well, we did. This is a perfect square. We had to square 3x to get this. What did we have to square to get 16? Well, we had to square 4 to get 16. So here's where the check comes in to see if this is going to work. This middle term here has to be 4 times 3x, so these two terms multiplied together times 2. Like in the last example, we had that 4x plus 4x. That's where this 2 in that formula comes from. It's 2 times 4 times 3x. So 4 times 3x is 12x, and multiplied by 2, do we get 24? We sure do. So with that check done, now what this turns into is if you're being very thorough, this turns into 3x plus 4 times 3x plus 4. But here's the thing though, 3x plus 4 times 3x plus 4, that's the same thing. We can write this as 3x plus 4 squared. Let's do the other example like this, and then we'll do the 4x squared minus 25. Let me get this cleared off so we can see this a little bit better. So we have 49x squared minus 14x plus 1. So we ask ourselves, did we square something to get this 49x squared? Yes, we did. We squared 7x. Did we square something to get 1? 1 squared is 1. Now the test is 7x times 1. Does that give us the middle term here? Well, 7x times 1 times 2. 2 of them. Well, 7x times 1 is 7x, times 2 is 14x. So we'll go ahead and write this as 7x minus, we go with this symbol here, minus 1 squared. And we're done. It's that fast. In the previous video, we did the Xbox method, which also works really, really nicely, but this is a lot slicker if you can recognize that. Let's go back to the difference of two squares that we had here. We had and this isn't drawing well, there we go. We had 4x squared minus 25. So, man, this pen is off. 4x squared minus 25. What did we square to get this? Well, to get 4, we squared 2. To get x squared, we squared x. And what did we square to get 25? We squared 5. So following our difference of two squares pattern that we talked about a moment ago, this turns into 2x minus 5 times 2x plus 5, or vice versa. You can swap those around and it's still the same expression. And it's that easy. It's that fast. There's one more example that I went over in class that I want to share again. Let's say I give you 36x squared. Let's do this as a plus. We'll do 81. Why not? And some people look at this and say, okay, well this is 6x and this is 9, and so it's going to factor. And then I'm like, whoa, hang on, guys, hang on, wait a minute here. This pattern only works as the difference of two squares. You have to be having a subtraction problem. We are adding here. Because we're adding here, this does not factor. This is not factorable. Not factorable. We cannot do anything else with it. So that is that example. So that's all I have on this one, and we will see you for the next video.